we've actually been using risk-based design in order to take us through the design process. And so I want to talk about that just a little bit. It's different than how we started in Orion. Typical NASA design, and doesn't matter whether it's a human spacecraft or robotic spacecraft, we typically write a set of requirements. And then we either internally as a NASA organization or we give it out to industry, here's a set of requirements, come back to me with a solution that meets all these requirements. And then we try to do some optimization once we see those designs. That's not how we started at all. We started with something we call a minimally functional design. A minimally functional design means that it's like buying a car. Okay? You walk onto a car lot and you tell the sales guy, I want to see the cheapest, most basic transportation you have. And he takes you over to the far corner of the lot and shows you a car that's got manual transmission, manual crank down windows, no air conditioning, plastic seats, you name it. It's basic transportation. Got the small little engine in it. And that's kind of what you start with. So that's how we started the lander design. We started with something called a minimally functional lander. And let's see, I got this somewhere here. There we go. And so a minimally functional lander basically takes all the things the lander has to do, and we come up with a design solution that meets all those functions, but not one iota more. In fact, it has no redundancy in it whatsoever. It has no way to respond to any off-nominal conditions. It is a lander that if everything went absolutely perfect, not a single component misbehaved during the whole flight, the crew would get through the mission. Well, obviously that's not a lander you would actually ever build. But what it does give you is it gives you the starting point on which to start adding back capability so that you build back the reliability, the safety into the design that you finally want. And you do it in this direction because, as Fred's finding out, it's much more difficult to try to extract these things later than to add them on in the beginning. And one of the cool things about starting with this basic lander and adding on functionality and adding on safety and adding on reliability is everybody on my team knows exactly what the mass cost, the dollar cost, and the risk reduction is for every component that we add back onto the lander. Now, it takes a long time to do this. We've spent the last year and a half, essentially, going through a design exercise where we first defined the minimally functional lander, then added back what we would call loss of crew risks, safety in other words, and then in another separate exercise added back loss of mission risks. And that's how we're building this lander up from this very basic design to something that's very, very robust. So that's the basic tool we're using in order to do lander design. So when you see things like minimally functional vehicle and our design analysis cycles, that's the tool we've used, the management and engineering tool to get the lander design to where we are now. And it's been really successful. It's been very educational for our team, but it takes a lot of time and a lot of patience. You have to make a lot of decisions. You have to make individual decisions about, in order to make my communication system, go from this level of risk to this level of risk, do I add an extra transponder? A similar one? Do I add a dissimilar one for dissimilar redundancy? Do I add a cable where I could patch it into an EVA backpack and use that comm system? Or do I really test the bejeebas out of that transponder so that I could get its mean time between failure numbers to be better? So we try to look at all different ways to reduce risk.